Now, ladies and gentlemen, this quantitative analysis, so many students who attempt this paper, because it's really at the foundational level, they end up getting a fail. Over 50% students who attempt QA, CASNEB registered students, over 50% who do QA in a sitting, most of them, over 50%, end up doing what you're failing. What do you need to do for you to be able to overcome this paper very fast? There are those topics that you must really be very good at. Those topics, if they give us a question from there, and you happen not to be knowing that question, then automatically you will get a 0. You will get a 0 in that question that everybody else is getting apart from yourself. Then automatically that would mean that you are repeating the entire thing. That would mean you are repeating the entire paper. So we shall start with topic number 1. Topic number 1. This is called mathematical techniques. Mathematical techniques. Mathematical techniques. And specifically, I would want us to look at calculus. I know I've done this before with some of you, but this is what I would want us to look at today, calculus. And this calculus, as I introduce it, this is the question that I'll be doing. I'll be doing this question with you. December 2023, question number 4. No, it's question number 1 actually. Question number 1, December 2023, question number 1, December 2023, question number 1C, SAFI Limited. SAFI Limited. So this is the question that I'll be doing, SAFI Limited. SAFI Limited. SAFI Limited. So this SAFI Limited tested us. And so many guys were not able to get this correctly. It wanted us to be good in what we call partial differentiation. In what we call partial what here? Partial differentiation. Very, very important. Partial differentiation. Partial differentiation. So can you kindly give me a signal once you are able to write up to here? Are you guys able to give me a Y there for yes? Are you guys able to give me there a Y for yes? So remember, you're getting this free of charge class from RCM College. RCM College is your #1 college in East Africa. Yeah. So this is our number if you want to make inquiries with us. This is our number if you want to get and make inquiries with us. 0719 525,000. And my name is Dr. Joshua Aura. I teach at RCM physical classes, that is at Stanbank House, first floor. And then we have RCM Online College, which I also do. Teach students virtually through Zoom, through videos, through our learning management system. And many students are really getting support regardless of their counties, regardless of their counties. All right. If I can get ink, I'll be very happy. Great. So then I've gotten a signal there. Guys are telling me that, Mwalimu, we have gotten the question. I've gotten a signal there. But before I do this partial differentiation, I would want to simply remind you on this differentiation, which is part of calculus. Differentiation is part of calculus. Remember, you have calculus. Calculus has got 2 branches. We have what we call differentiation. And then number 2, we have what we call integration. So we have differentiation, and then number 2, we have integration. But today, the knowledge that they want us to use today is called the differentiation. Specifically, what we are calling here, partial differentiation. But you see, before I do it, I'm so sure there will be a few students who are very new. I would want, in this case, here to take them through what we call differentiation, introduction bit of it. Introduction bit of it. I will be your pilot. Of course, I'm calling myself a pilot here, not a ninja. So I'll be able to steer this class for exactly 1 hour because it's going to 2 p.m. We recognize that some of you are still working. Some of you are working. They would want that by 2 p.m. They should be able to go back to their work places by exactly 2 p.m. So the lesson will take exactly 1 hour. So, and we are doing differentiation here, which of course will be able to boil down to differentiation, partial differentiation, to help us in answering this. So if you remember, differentiation is used to ascertain rates of change. It's used to ascertain rates of change or gradients along functions. Rates of change or gradients along functions. So if you are given a function of this nature, y equals ax raised to power n, and then somebody tells you to differentiate, to get dy over dx. How do we get dy over dx? It will be this n comes down. So it gives us what we call nux. Nux, like Nakuru, nux, and then we got to this power n minus 1. So we normally do two things. The power comes down, and then from the old power, we shall be subtracting, in this case here, 1. From the old power, we shall be subtracting 1. So nux into n minus 1. What do you mean, Mwalimu? So if, for example, as an exercise, you are given here like y equals 10x raised to power 5. Let's apply the nux rule. So the 5 comes down. When this 5 comes down, it will be 10 times 5. 10 times 5. So then my dy, because when you say dy dx, this means you're differentiating. Dy dx means you're differentiating. So when I bring this 5 down, it knocks on the 10. 10 times 5 gives me 50. X raised to a new power. How do I get this new power? To get the new power, we take the old power minus 1. To get the new power, we take the old power minus 1. So is there somebody who is able to see a 4 there? Is there somebody? I mean, ladies and gentlemen, we have to talk. We must talk. You must assist Mwalimu here. You must assist Mwalimu here. Yeah, you must assist Mwalimu here. You are not audible. Mine is really showing that I'm really audible. Is it the case for everybody? Are you guys able to hear Mwalimu? Are you guys able to hear Mwalimu? Please help me out. Yeah. So chances are then that gentleman, you have to tell them to basically log out, and then they come back. They log out and then they come back. They log out and then they come back, because my system here is showing me that I'm very audible. I'm very audible. I'm very audible. I'm very audible. Now, ladies and gentlemen, please listen and listen to me very well. What if, for example, you are given something like this? What if you are given something like this? Y equals 30x raised to power 2 plus 40x raised to power 3. Can somebody try differentiating this for us? It doesn't matter how many terms you have. We're going to differentiate one term at a time. We're going to differentiate one term at a time. So how do you differentiate this? The n comes down. When it comes down, it knocks on this 30. So it gives us 60, x raised to a new power, a reduced power. We simply take the older power, we subtract 1. We take the old power and subtract 1. So initially we had a 2. 2 minus 1 gives me 1. Power 1 is always silent. Power 1 doesn't speak. Power 1 is always silent. Plus, in this case here, these 3, we differentiate it. So this 3 comes down. 40 times 3, this gives me 120. X raised to our reduced power, which is a new power. How do we get this new power? We've just said here, to get the new power, you take the old power, you take away 1. So in this case here, this will give us 2 like that. This will give us 2. So another exercise, ladies and gentlemen, and this I would want to throw it to you. Y equals 60x plus 100. I would want to see whether there is anybody who will be able to differentiate this. Let me see whether there is anybody who will be able to differentiate this kindly. Let me see whether there is anybody who will be able to differentiate this. Remember, you're getting this free of charge class from RCM College. And once I do this kind of an introduction, we have a very good learning management system. This learning management system, we've been able to put all the videos, especially videos for last semester. So what I normally do to cover the syllabus, I simply give like an introduction, do 1 or 2 questions from the past paper, and then I'm able to send you guys to a learning management system where now you'll be able to get like further reading materials in form of notes and in form of notes and videos. So if you're interested in our services, this is our number 0719525000, and we charge Kenya shillings 4,800 for Zoom. That's per subject. For Zoom and the LMS, Learning Management System. So I can see RISPA there. So she's giving me here dy over dx. Do you know that there is an implied raised to 1 there? There is an implied raised to 1 there. When we bring this 1 down, it knocks on this 60. It gives us 60x raised to power 0. Why power 0? Because of 1 minus 1. 1 minus 1, that gives us 0. What happens to this 100? This 100 is a constant. 100 does not have x. 100 is a constant. Constants will always disappear whenever they are differentiated. Constants will always disappear. If I were you, I would have written this somewhere there in my mother tongue, that constants always disappear. It doesn't have x, it's a constant. Its gradient will be 0. So if it's a constant, it disappears. But now remember, again in mathematics, that if you raise anything to 0, anything raised to 0 is 1 in mathematics. You can try this there in your calculator. Just take like 100. Somebody do this for me. Take 100 raised to power 0. Say 100, there is a raised function, 100 raised to power 0 like this. You'll be able to get to 1. 100 raised to power 0 is 1. Is there somebody who is able to get that 1? 100 raised to power 0. Please ensure that you're able to raise. Your raised in your calculator is like this. So you say 100 raised to 0. Somebody please talk to me. Is there somebody there who is able to get that 1? Is there somebody who is able to get that 1? Yes. So anything raised to 0, be it a letter, be it whatever, anything raised to 0 is always equal to what here? Is always equal to 1. Is always equal to 1. So in this case here, x raised to 0 is 1. So this is the same as saying 60 times 1. And that is why you saw so many guys saying that dy over dx equals 60, because 60 times 1 is 60. 60 times 1 is 60. So if you allow me, before I start doing this question of December 2023, I would want us to do like one more exercise here. Just one more exercise. One more exercise, what do we have? If, for example, you are given here y equals 1000x raised to 3 plus 40x plus 300, and then they tell us to differentiate. Differentiate is to get the gradient, is to get rate of change. They tell us to differentiate, give them dy over dx. So dy over dx, is there somebody who can try differentiating this for me if you don't mind? Somebody in this case here, try differentiating this for me if you don't mind. Someone try differentiating this for me if you don't mind. Let's see what you guys are getting. And thank you very much. How I wish you would really share this link that you have used to enter here with all your friends. We have one objective, to make RCM bigger and better. So we need numbers. With your support, of course, we shall be able to double our numbers. Currently, we're supporting about 2,000 students spread across East Africa. Like now, you guys, if you are to be very honest with me, I'm so sure here there must be somebody who is joining me from Nairobi, another one from Bungoma. I mean, I'm so sure. I mean, we support students all over. Right now, of course, the 4 walls of a classroom have been broken down by Zoom. Has been broken down by Zoom. Plus 40. Thank you very much, Rispa. Thank you very much. Thank you very much, Migichi, Linda. All right. So now a dy over dx, the 3 comes down. This 3 will be able to knock on this 1,000. So it gives me 3,000. X raised to a reduced power. So the reduced power will be 3 minus 1. 3 minus 1 gives me 2. Plus, there is an implied 1 there. So 1 multiplied by this gives me 40. 40x raised to a new power, which will be 0. So if it's x raised to 0, I'm better off not writing x raised to 0 because I know that is 1. And you see 1 times 40 is 40. What happens to this 300? This 300 is a constant. And the constants always disappear upon differentiation. Constants always disappear upon differentiation. Now, we want to go to this. Now, we are talking about partial derivatives. Partial derivatives. Partial derivatives. Now, we are talking about partial derivatives. So, partial derivatives basically are, or rather is, that system of differentiation that will be used in situations where your equation has many independent variables. If you have many independent variables, for example, you're given something like this, y equals 10x raised to power 3, not y, but w raised to power 2, plus 100, x raised to power 4, w raised to power 5, plus 1,000. So this one, I can only differentiate it partially. I can only differentiate this partially. So how do I get to differentiate this partially? I will start with dy with the first variable. So I'll do dy over dx first. And then I'll be able to do dy over the W. So I differentiate the whole function partially with the X and then partially with W. So let me start differentiating this with respect to X. Remember, what am I after here? I'm after making changes in the structure of X because I'm differentiating with respect to X. So W will remain and will not change in terms of structure this time round because it's a partial differentiation. I'm differentiating this with respect to X. So I can only be affected with the power of X here. So the power of X here is 3. So this 3 comes down. When this 3 comes down, it means this 10. So it gives me 30 and the power of X must come down. So the power of X comes down to 2. W will remain with its power. I'm not changing the structure of W. I'm not changing the structure of W. Then come here, ladies and gentlemen. So here, what do we have? The power of X is 4. So this 4 comes down. That gives me 400. X raised to 3. The structure of W remains. But when I come here, ladies and gentlemen, that 1,000 is a constant. That 1,000 is a constant. What happens to constants? What happens to constants? Somebody talk to me. What happens to constants? What happens to constants? Somebody talk to me. Constants shall always disappear upon differentiation. Constants shall always disappear upon differentiation. They shall always disappear. A derivative of a constant is 0. I like that. A derivative of a constant is 0. I like that. So then can you kindly help Mwalimu to get dy over dw here? Remember, we go back to the original equation. Let me see whether there is even a single student who will be able to get the first term derived. Let's see whether we will have somebody who will be able to derive the first term. dy over dw, dy over dw, dy over dw with respect to w now. Now remember, it is only the structure of w that can change. It's only the structure of w that can change. It's only the structure of w that can change. So we're giving you these great classes here from RCM College. We have CPA trainings for all the CPA papers, be it business data analytics, all the CPA papers, and we have all classes for you right from very early in the morning to evening. If you want to take classes, we have them. If you really need to study with us, this is our number, 0719 525,000. 0719 525,000 is our number. Thank you so much. Ruth already has an answer. Ruth already has an answer. Thank you so much, Ruth. Who else has an answer? This differentiated with respect to W. Differentiated with respect to W. Thank you, Ruth. That's quite a very good trial. Remember again, online, you must be very active. You must be proactive. Online classes, you can't afford to take a backbench and you expect to pass. If you take a backbench, you're not giving us any answers at all, you're not giving us any trials at all, you're not asking any questions, then that will be a recipe to failure. Otherwise, somebody who keeps on asking questions, somebody who keeps on talking, they always like this subject a lot. Always. So then, ladies and gentlemen, here we are. To differentiate here with respect to W, you see W here has got power 2. And it is the one that you're chasing. So its power will have to come. You can't write that power inside here, no. Its power will have to come right in front. So it means 10. So 10 times 2, that gives me 20. X is not changing in structure. This time around, X is the one not changing in terms of structure. But you see, W's power will have to go down. W's power will have to go down. W's power will have to go down. So this will be W raised to a new power, which is 2 minus 1. So it becomes 1. 1 is silent. 1 is silent. 1 is silent. How about this? Can somebody in this case here try differentiating this for me? Please try. Just differentiate this for me. Just one term. With respect to W. Just one term. Just try. Even if you don't get it right, so what? You've tried. We are learning by making mistakes, as many mistakes as possible. Just try. Just try. With respect to W, just try. With respect to W, just try. Just try. Just try. We get to see. 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 Nobody's trying, but we shall overcome. But of course, I know you guys have got good intentions. You must be writing something. So you see here, we are chasing W's. We are differentiating with respect to W. The W has got 5 on top. So it is this 5 that will always come to the very front here. It multiplies this, so it gives us 500. Thank you very much, Judy. Thank you very much. Thank you very much. Thank you very much. So this comes here, so it gives me 500, x raised to power 4, x will remain. And then now we have w raised to a new power, which is power 4. This is a constant, meaning that it will disappear. It will disappear. That's a constant, meaning that it will disappear. So can I go to the next thing, or is there somebody who would want me to repeat this concept? Please, I'm your father in the industry. I don't feel bad when I'm told to repeat. Actually, I feel very nice. A good person should be able to feel good whenever you're helping. So when I hear somebody asking me a question, I'm normally privileged, to answer, because I'm always happy. I'm always happy to do what here. I'm always happy to help. 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 No question. So can I continue now? Can I continue? Can I continue? Can I continue? You guys, you have to really say something there. Yes. Thank you very much, Rebecca. Yes. Thank you very much. Now we are doing this question of December 2023. December 2023. December 2023. Question number 1, cow. December 2023. Question number 1, cow. Do you have the question paper? So this was a very interesting question paper. They gave us P1. P1 equals 1200. P1 equals 1200 minus 2x minus 2x minus 5y. That is P1. And then we have P2. P2, what is our P2 figure there? It is 1700. It is 1700 minus 3x minus 3x minus 2y. Minus 2y like that. That's what they gave us. Yeah, we shall upload it, Edward. Yes, we shall upload it in the LMS. That's very important. So they've told us there, Safi Limited manufactures and sells 2 types of cleaning pads, OSHA and OGA. The demand functions for the 2 products are given below. So these are the 2 demand functions, where P1 is the unit price of OGA, P2 is the unit price of what here? Is the unit price of OSHA. One is OSHA, the other one is OGA. X is the quantity of OSHA, X, quantity of OSHA, and then Y is the quantity of OGA. So the total production cost of the 2 products is given. They have told us here the total cost will be equal to 230x, will be equal to 230x plus 90y, 230x plus 90y like that. So what do they want me to give them? They want me to give them the profit maximizing output. The profit maximizing output. They want me to give them the profit maximizing. Whenever they tell me to maximize things, I know if I start climbing up a mountain, it will move like this. I will ascend, reach this point that we call a stationary point. This stationary point is what we are calling maximum profit. And at the stationary point, if you do a tangent, the tangent will be flat. Will be flat, having dy over dx as 0, having a gradient of 0. So the tangent there will be flat. So whenever you hear of profit maximization, they are testing you, or profit optimization, or cost minimization, they are testing you on this concept of tangency. They are testing you on this concept of what a differentiation. Now, please listen. What do they want me to? What do they want me to differentiate? You see, they want me to maximize profit. 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 How do I maximize profit? First, derive the profit function. Derive whatever they want you to maximize, derive the profit function. So first, derive the profit function. First, derive the profit function, because they want me to maximize profit. If they want me to maximize profit, then the very first thing that I will do is to look for that function that they want me to get, which is profit. We are very lucky, ladies and gentlemen, because we know one fact. We know one fact. The question that I'm doing is December 2023, question number 1C, and I'll not get tired reminding you that you're getting this class from RCM College. Our number is 0719525000, and the name of the ninja here teaching you, I call myself the Chief CPA Ninja. The name of this ninja who is teaching you here today is Dr. Joshua Aura. Dr. Joshua Aura. Yes, Oyugi, I'm recording. Thank you so much. I'm recording. This is being recorded. And I'll be able to upload it on my YouTube channel. So then I take this opportunity to welcome all of you to RCM. Get to join this award-winning institution for your classes. We have online classes, and then we have physical classes. We have physical classes at Stanbank House. RCM, Stanbank House, first floor. You'll be able to get very good services over there. But most of our students, majority of our students are studying online. So we know one thing, that our profit is normally abbreviated like this, pi. So here pi is 122/7. This is a symbol for profit. To get profit, we normally take total revenue minus total cost. To get profit, we normally take total revenue minus total cost. Please write this in full. This is total revenue. This is total cost. So you look at how much money is coming in, total revenue, minus how much money is being spent, total cost. Now here I have two products. So what I'll do to get total revenue, I will take total revenue from OGA or OSHA, whichever, plus total revenue from where here? From OSHA. So I'll be able to add the two. But now, ladies and gentlemen, assuming I'm selling pens of this nature, I'm selling pens, and one pen is going for 10 bob. On a given day, if I sell, for example, 50 pens, quantity sold is 50 pens, would you kindly tell me how much revenue will you say I have generated? How much revenue will I have generated if on a given day I sell 10 and out of 50 pens, each at 10, each at 10? How I wish these guys were talking to me. How I wish these guys, of course, I know most of them are very new to me, but you see, I'm a good person, very good person. So RISPA is telling me 500, Jacinta is telling me 500. How do they get this revenue? These great people have just taken the price per unit times quantity. So anytime they want you to get revenue, ladies and gentlemen, we shall always take price times quantity. Revenue is price times quantity. Revenue is price times quantity. I should never forget that. I should never forget that. So I would want us to start with the product one. Product one. So for product one here, I want us to get total revenue one. How will I get this? Remember, total revenue is price times quantity. So total revenue one will be equal to the price. I can see price one is here. Price one is 1,200. Price one is 1,200 minus 2x minus 5y. So I have to put this in brackets. That's price one. Price one. Price one has many terms. I have to put them in brackets. Come and multiply this by quantity one that was sold. Quantity of product one, of which they've told us there that for X is the number of units of the first product called OSHA. So in this case here, ladies and gentlemen, total revenue for product one will be price for product one that is here, times quantity of product one that was sold, which is what here? Which is X. So using distributive law, go ahead and distribute this inside. Therefore, our total revenue one will be, if you distribute this, it's going to multiply each one there. So this will be 1,200x minus 2x squared, because I'm multiplying each one of them. Minus, you can't say 5yx, x comes all here. So it will be minus 5xy. That is total revenue one. So please assure me that we are together by just writing there y. If you are together, if you're not together, please ask questions. Feel free to ask questions, please. Even one question, please. They are okay. Then go ahead and give me total revenue two. So how do we get total revenue two? We need price two, because this is the formula. It's price two times quantity two now. So the second price here is 1,700. This is 1700 minus 3x minus 3x minus 2y. This is the price times the quantity. So if you're following, which quantity do I put outside here for the second product? If you're following, which quantity do I put outside here? If you're following, for the second product, it is y. You guys are geniuses. For sure, you guys are very bright. For sure, you guys are very bright. So that is total revenue 2 that you must go ahead with opening of brackets. You must go ahead to open brackets here. So this will be 1700y minus 3xy minus 3xy minus 2y squared. Because I'm multiplying each one of these. As we mark this in class name, most of the students do not know how to open. They don't even put brackets. You know, this is supposed to be like one number, but it has different terms. So we must encapsulate all those terms in brackets, and then we put outside y there. And then now we should be able to distribute the y to each of those terms. So it's not lost on us. To get the total revenue of the farm, we will take the total revenue of Oga plus total revenue from OSHA. So basically, I'll come and reiterate here the fact that to get total revenue for the farm, this is what we are doing. To get total revenue for the farm, it is TR1 plus TR2. So to get total revenue of this farm, it will be TR1 simplified, which is 1200x minus 2x squared minus 5xy, in this case here plus total revenue 2, which is 1700y minus 3xy minus 2y squared. So remember, it is total revenue 1 plus total revenue 2. I don't have to put them in brackets because whenever I'm adding, addition, the sum, this adding sign is not very powerful. It can't change anything. So whenever you're just adding two functions, don't put them in their respective bracket. It will be a waste of time. So go ahead and in this case here, put like terms together. The only like terms that I'm able to see here, the only like term that I'm able to see here is this and this. Those are the only like terms. All the others are unique. They are unique. So we start writing this. So our total revenue will be 12. So this one here is unique. I simply bring it with a sign. This is unique. I bring it with a sign. But now this has a partner. So this will be minus 5xy minus 3xy. What are we able to get there? Minus 5 minus 3. Minus 5 minus 3 gives me what here, somebody? This is minus 5 minus 3. Somebody talk to me. Minus 8, isn't it? Not minus 2, minus 8. Because it is minus, you pick this with a negative. Minus 5 minus 3. So this gives me minus 8xy. This doesn't have a partner. So plus 1700y plus 1700y. So I'm through with this. And then now we have minus 2y squared. Great. This is total revenue. But the fact is that we haven't yet reached home, because home was all about profit. Home is all about profit. So let's go on and now get the profit. Let's go home and get the profit. To get profit, ladies and gentlemen, we are taking total revenue minus total cost. To get our profit here, the total revenue, do we have total revenue? Oh, yes, it is here. It is 1200x minus 2x squared minus 8xy plus, in this case here, 1700y minus 2y squared, but now minus. So minus. So the term that I'm supposed to come and pick and deduct here is total cost. I'm supposed to come and deduct total cost. And this total cost is coming in terms of two terms. All right. So it is 230x plus 90y. If you write it and then you leave it like this and then you continue, you will be absolutely wrong. This total cost is supposed to be one number, albeit the fact that it has got what different terms. So it means that I must deduct all the terms. I must put the terms that I'm deducting in brackets here. Otherwise, I'll get a 0 in the entire question. So many guys forget this. I've marked CASNEB exams for so long. So I know what the petty mistakes students make. Students are bright, but they keep on making petty mistakes. So then we go ahead and open brackets. So my profit here will be 1200x minus 2x squared minus 8xy plus 1700y minus 2y squared. So now remember minus, when minus is outside, minus is a very, very powerful sign. So this hits a 2. Earlier on, this was a plus. Now minus has to change it. So it becomes minus 230x. This becomes minus 90y. So before I proceed, again, I would want really you guys to tell me whether we are together by mentioning y for yes. I don't really wish to move very fast. Of course, we are time pressured because I have less than 20 minutes. But at the end of the day, it's really about you understanding. It's not about finishing the question. We'd rather leave the question halfway. We finish tomorrow or something. But whatever we do, we understand. But from what I'm seeing here, is like we are more than together. The students who are online are very, very happy. Are very, very happy. Now from there, let's put like terms together. So like now this and this are like terms. So remember, I read this as positive 1200 minus 230. Can you kindly give me an answer? 1200 minus 230. Kindly give me an answer. My profit here will be equal to what here? 1200 minus 230. This will give me 970x. So minus 2x squared doesn't have any like term. So you simply tick it and bring it with a sign. And then we have minus 8xy. Do we have another xy? No. So I bring it here, minus 8xy. I put a tick like that. But this 1700 has a like term. It is a like term to this. So it will be 1700 minus 90. So this is a y term, that's a y term. So 1700 minus 90 gives us what figure? 1700 minus 90 gives us what figure? 1610. So this is plus 1610y. This doesn't have a like term. So you come and give us here 2y squared like that. And I think you've been able to bring all the terms. So then, gentlemen, then we have our profit equation. They wanted us to shoot up there onto the sky and be able to reach a stationary point. They wanted us to shoot like a football up there and maximize it and maximize it. So this is what you need to do. Whenever they tell you to, for example, maximize revenue, if they tell me to maximize revenue, then I have to get revenue and then I shoot to maximize, I shoot. How do we shoot? So we have been able to we have been able to derive the profit, which is 970x minus 2x squared minus 8xy minus 8xy minus 8xy plus 1610y minus 2y squared like that. So I would want to shoot this up there. I would want to maximize these. So to maximize this, shooting goal, shooting shoe, we normally call it FOC, first order condition. To take it up there to the hill, to maximize it, first order condition. So first order condition tells me to differentiate this. So as I start differentiating, I realize, hey, this has got x, it has got y as well. No problem. So I'm going to use what we call partial derivatives. So I'll come and say d profit over dx. So d profit over dx. So now I'm only chasing the terms that I've got x. So can you kindly then give me this answer? Kindly give me this answer. 970x differentiated gives me what here with respect to x? It has got x. Anybody who is able to give me this answer? Anybody who is able to give me this answer? When you differentiate 970x, so Emily tells me, yes, Mwalimu, we have got a 1 here. So when this one comes down, it gives me 970x raised to a new power. How do we get new power? 1 minus 1, which is x raised to 0. I'm better off not like writing x there. So I'm chasing after x. When I differentiate this with respect to x, this becomes minus 4x. How about this one here? Somebody try this out. When you differentiate this with respect to x, what will you get? If you get this, you are a genius. When you differentiate this with respect to x, what will you get? If you differentiate this very well, then automatically you're a genius. And I should be able to give you a gift. Judy, I can see the answer you have there. Judy, I can see the great. So this one, when I differentiate with respect to x, of course, I know there is a 1 there. So this one comes here, gives me 8, x raised to 0. But you see, y will remain because the structure of y is not being changed here. So this becomes minus 8 what here? Minus 8y. How about this differentiated with respect to x? There is no x here. So if there is no x here, the whole term becomes a constant, disappears. We also don't have x here. So when we don't have x in a term, then you can't tell me that that term remains in terms of structure. The whole thing goes. That's like chameleon. You chase it away with it's a twig. It goes, everything. So because we don't have x, then it cannot appear here. It disappears like that. So remember, as I shoot, in this case here, this ball to the sky, at that stationary point up there, the gradient is, that's why we are calling them stationary points. The gradient is 0. So you must equate. First order condition, a derivative is always equated to 0. A derivative is always equated to 0. Then you come here and they give me the profit over dy. So d profit over dy. Let me see whether there's anybody who will be able to get this correctly. D profit over dy. So d profit over dy, of course, no y here goes. No y here goes. This will give me minus what here? Somebody who is able to follow with respect to y. With respect to y, somebody write for me there. With respect to y, what do we have here with respect to y? Minus 8x. Thank you so much. Minus 8x. With respect in this case here to y, this will give me 1610. 1610. With respect to y, this will give me minus 4y equals 0. I would want this to be two simultaneous equations. I would want this to be two simultaneous equations for me to solve this. So I'll be able to take this to the other side. So it will be minus 4x minus 8y equals minus 970. Equation number 1. Equation number 2, it's minus 8x minus 4y. This crosses over the other side. Here it's positive. On the other side it becomes negative. Negative 610. Equation number 2. So I would want to eliminate x. So I would want this to be 8 as well. I would want to eliminate. So I would want this to be 8 as well. So then what do we do here? So for that to be 8, this equation number 1 has to be multiplied by 2 for this to be negative 8 now. So I want to multiply each one's, all this by 2, all this by 2 for equality to hold. So this one here will give me minus 8x, minus 16y, minus 16y, who can now give me this figure. This one here will be minus what here, somebody? What is 970 times 2? What's 970 times 2? What's 970 times 2? Minus 970 times 2, somebody help me, minus 1940. So we have here minus 1940, that's equation 1 times 2. And then equation 1 now, equation 2, will be left as is. So minus 8x minus 4y equals minus 610. So equation number 2 like that. So then I would want to eliminate. Remember elimination. Elimination whenever the signs are the same. Negative, negative. For you to cancel everything here, whenever the signs are the same, you subtract. If, for example, this was a plus and this was a minus, I would have added to bring them together to 0. To 0. But now you see here they are minus, minus. So if I want to cancel this, to eliminate this, to make it 0, so I subtract. So when I subtract like this one here will be minus. If I have a calculator, this is very easy. If I have a calculator, I will say minus 16, minus, and this is minus 4. So minus 16 minus 4. Can you kindly give me that answer? Minus 16, then there is this minus, and then this number itself is minus 4. Can you kindly give me this value? Minus 16 minus 4. Can you kindly give me this value as we finish now? I only have very few minutes. I only have very few minutes. I only have very few minutes. Use your calculators always. Use your calculators always. So I'm being given here minus 12. So this will be minus 12y. Minus 12y. Nobody else has given me the answer except Linda. I don't know whether they have a challenge because, you know, you can't read a number without its sign. So especially when you have a negative sign in front of it. So this will be minus 16. The minus for elimination, minus 4. So then we have here minus 16 minus 4. Can somebody confirm that this minus 12 is correct before I continue? Someone else. Can you kindly say there y for yes, and I'll be happy if it's minus 12. Or if you're getting a different answer, tell us. Minus 12, Jacinta has confirmed. Equals, how about this one? Is very easy. It's minus 1940. We have this minus 1610. Minus 1610. So we've got 2 here. Minus 1940. Minus here. Minus 1610. What are we getting there? Minus 1610. What are we getting there? Abracadabra. What are we getting here? Abracadabra. What are we getting here? What are we getting here? So please give me your answers without fearing anybody. You must always keep on providing answers. You must keep on providing answers. So according to Linda, it's minus 330. Minus 330. Is there somebody who is able to confirm this? Sylvia's confirmed. Thank you so much. I want y. So it will be minus 330 divided by 12. So is there somebody who can give me this final answer here? Divided by minus 12, sorry. Divided by minus 12. Divided by minus 12. So kindly give me the value for y. Please give me the value for y. So minus 330. Yeah, don't round off too much. Don't round off too much, Migishi. Just write here 27.5. Don't round off too much. Thank you so much. Even if it's a product, don't round off too much. Now, after you do that, ladies and gentlemen, now you can substitute for y in any of the two equations, you know. You can come and substitute for y in any of those two equations, and then you're done. So come here pretty fast. Pretty fast. In this case here, tell us what is the value of x from equation 1 or equation, it doesn't matter. So equation 1 is here. It is 4x minus 8. Fortunately, we know what y is. Minus 8y. So y is 27.5 equals minus 9. So I've basically written equation 1, but plugged in y because I know what the value of y is. So then 4x, who can give me this 8 times 27.5? Is there somebody who can give me 8 times 27.5? I'm almost being left alone here. Is there anybody who can give me? So Migichi, again, this must be a very good student. She's giving me 220. Sylvia, thank you so much. Minus 220 like that. Equals minus 900 what here? Minus 970. Remember this is negative. I mean, how did I leave negative out? It's supposed to be negative, negative like that. Negative. Remember equation 1 has got -4 there. So then we want to make x the subject of the formula. So to make x the subject of the formula, then this 220 has to cross over to the other side. So it will be minus 4x equals minus 970 plus 220. So minus 4x will be equal to what on this other side? Will be equal to what on this other side? So minus 970 plus 220 gives me what figure? Gives me what figure? So according to Linda Migishi, this is minus 750. Minus 750. So meaning that x will be equal to minus 750 divided by minus 4. Minus 750 divided by minus 4, which will end up being equal to what? Which will end up being equal to what here? Which will end up being equal to what here? So according to Migishi here, we have 187. Migishi, 187.5. 187.5. 187. Can someone else confirm this answer? Can someone else confirm this? So if these guys here want to maximize their profits, then x should be this number and y should be that number. And then they went ahead to ask us in Roman 2 to give them the total profit then to be realized. So they want us to give them the total or the maximum profit. They want us to give them the total. So the last thing, they want us to give them the total profit. At times they call it maximum. At times they call it maximum profit. What do? We shall be able to substitute for the quantities that we have in this profit equation. In this profit equation. So then this is what we have at the end of the day. My profit will be 970x. X, which is what here? X, which is 187.5 minus 2 times 187.5 square. I'm following this. I'm substituting there. I'm plugging in numbers there. Minus 8xy. So minus 8 times x is this 187.5 times y. Y, which is 27.5. All right, all right, all right. So we continue with the journey, ladies and gentlemen. We are continuing with this journey. Plus 1610y. So plus 1610y, which is 27.5. Minus 2, 27.5 squared. So you don't do like these things one at a time. No. What you do, you take your calculator and then you press the 97 times this, minus this times this square, minus 8 times this, plus 1610 times that, minus 2 times that squared. Minus 2 times that squared, and then you're able to give us an answer. You are able to give us an answer. You are able to give us a final answer. You're able to give us a final answer. You're able to give us the final answer. You're able to give us the final answer. And this thing could not end at a better time. I mean, it's only a few minutes to 2 p.m. and here we are. It's only a few minutes to 2 p.m. and here we are. It's only 2 minutes to 2 p.m. and here we are. So is there somebody who is able to give me this profit? So let me see how much they will get. Let me see how much they will get. And how I wish you guys can really go out of your way to make RCM College the most popular college in East Africa. That, yes, you can. That you can. That you can do it. That you can do it very well. 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 Very well. Very easily. By giving people there, outside there, our number. This is our number 0719525000. Anybody who wants to do CPA, CFA, CS. So according to Migishi Linda, this is supposed to be 113,075. 113.75. So is there somebody else who can confirm this? Yeah, 113,075. So ladies and gentlemen, we have come to the end of our session today. I'll be having a similar session tomorrow at 1 p.m. Tomorrow at 1 p.m. And I'll be able to post this video on YouTube. Once you get my video on YouTube, then I expect you to do what you have to like the video. You must, in this case, subscribe. If you go to YouTube and search for Joshua Aura, you'll be able to get me there. Support Mwalimu. So go to YouTube, look for Joshua Aura. You'll get, I've done so many videos on this quantitative analysis. So for the students I've never taught before, that today is your very, very first time I've taught you. Can this chief CPA ninja make a very good teacher? Can this CPA chief ninja make a very good teacher? Give me your honest opinion. Or is he the worst teacher? Is he the worst teacher? Is he the worst teacher? All right. So I'm getting, in this case here, one, they have faith. The best. Oh, great. So again, what I would want to know, are you ninjas here? I normally call my students ninjas. Are you students at RCM already? Thank you very much, Rispa. Are you students of RCM already, or are you studying elsewhere? Are you students of RCM already, or are you studying elsewhere? Taking QA, great. So at least I am great. I'm looking for non-students of RCM. Do we have anybody who is a non, yet to stay till the end? Do we have any student in this case here who is not in RCM? Great. I can see most of you are in RCM. So then you guys will have to do me a favor. Tomorrow when I share with you the link, ensure that you share it with your friends. Tomorrow I would want you to come with guests. Can we call it bye-bye? Thank you very much for giving me a good audience. Thank you and bye. Goodbye, yes. See you tomorrow. Thank you.